What's up, 10C? Hopefully you guys are all staying healthy and up to date on your academics out there. Also, hopefully you have finished the polynomials tests prior to watching this video and attempting the associated homework and quiz. So today is the first lesson on slope. It's in the first unit of relations and functions, which is, I break up into 3 units usually in Math 10C. The first unit is mostly based off of terminology and getting some background knowledge before we progress into problem solving and determining equations for relations and functions. However, I am just going to highlight some of the main key points in the first unit that you need to be successful in future math. If I have time, I'll come back to the rest of them, but for now I'm just going to choose some important topics that you need to understand moving forward. That means if you're trying to follow along in my note package follows the order that I would usually go through it. So the relations and functions note pack, pages 19 to 22 are the notes that are associated with slope. So let's get into this. So you should have already talked about slope in Math 9, and so another name for slope is rate of change. Slope is equal to the m value. And so if you have an equation like y equals mx plus b, that m value is going to be your slope of a line. And that can tell you a lot about a line. It can also help us solve for other problems. So we need to be able to find slope. There are several ways that we can calculate slope. You should know one of them, and the first one is that the slope is equal to the rise over the run. The second equation here is that slope is equal to the change in y over the change in x. And we represent change mathematically by this delta. So delta y over delta x, which just means the change in y over the change in x. If you've already done physics in science, you might recognize that that's close to this formula v is equal to delta d over, delta t. Well, that's the change in distance over the change in time. And it's almost identical to this formula, except, my variables are different. But looking at the change in both of these values, those are really just a rate of change. So velocity is just a rate of change. So if you had a graph, the slope of the graph would be equivalent to your velocity. Just so we know, delta y is equal to y2 minus y1. And over delta x, which is x2 minus x1, okay? This formula for slope is on your formula sheet. You are given it. So if you do not already have a formula sheet printed out or handy, I would keep one on you when you're, looking at homework questions or doing quizzes. So let's go take a look at this formula. First of all, I want to review or make sure we can kind of find the slope using strategies we already know. So m is equal to the rise over the run. And they already gave me 2 points on this graph. They said, okay, here's this point and here's this point. What is the rise over the run? Well, the rise here would be I'm going up 3 and I'm going 4 to the right, so plus 4. So the rise is 3, the run is 4. So that means the slope of that line is just equivalent to 3 over 4. Well, let's go verify that this other formula that we have, that m is equal to delta y over delta x, let's make sure that that also works for this particular question. In order to do that, we have to remember, first of all, how to find points on a graph. Remember, this axis is the x-axis, and the vertical axis is the y-axis. And any point that we are given on a graph always comes in this form, x comma y. So if I wanted to plot point A, let's say, at 5 comma 1, well, I would go 5, 1, 2, 3, 4, 5 on the x and up 1. So that would be point A. If they said, well, here's B, what's the coordinate of B? I would do the same thing. I need to figure out how far it is on the x. So this is 5, 6, 7, 8, 9, 10 on the x. And it's 1, 2, 3, 4 up on the y. So that point B is at 10, comma 4. So for the question that the question we're looking at here, well, we need to go find out what these points are, what those coordinates are, to be able to substitute them into this formula. So this first point is at 1, 2, 3, x, and 2 on the y. So there's a point at 3, 2, and another point at this point right here. So that's at 5, 6, 7. Oh, wait, no, that's 5, 6, 7 right, and 1, 2, 3, 4. So 7, 5. So there's a point at 7, 5. All right. Now that we have our two coordinates, now whether we're given a graph or whether we were just given any two coordinates, we can now take that information and substitute it into this formula. So I need to go designate x1, y1 for these points. Usually I just kind of go through it in whatever order it gives me. Well, this is the point x, y, and because it's the first point I have, that's going to be x1 and y1. Because this is the second point, this is just going to be x2, y2. I could switch the order of those, it doesn't really matter, but I can't go and say, oh, this is x1, y2. Okay, that doesn't work. They both need to have the exact same number, and as long as they're the exact same number, when you substitute them into here, you'll get the correct slope. So that means I'm going to take these numbers and substitute them into the formula. So m is equal to y2, so 5, minus y1, which is 2. So 5 minus 2 is 3, over x2, which is 7, minus x1, which is 3. And 7 minus 3 is 4. And so regardless of what strategy we're choosing here, rise over run, or using the points, we should be getting the same slope. Okay, so here they gave me some graphs, and they say, here's the slope. Generally, anytime I have a graph, I am going to use, so if I have a graph, use m is equal to the rise over the run. Unless it's kind of like a weird graph, and you can't figure out the scale, something like that, then I would use something different. But if I have a graph, generally I'm using the rise over the run. So I want to find two kind of like what I like to call like perfect intersecting points, which seems to be pretty hard on this one. Let's say there's a point here and a point here. So the slope for this one, m, is equal to the rise. So this goes up to, whether you put a plus there or not, it doesn't matter. So up to, and 5, so 5 right. So plus 2, plus 5, so m is just equal to a positive 2 over 5. That's for that graph. The next one is if I have a point, let's say here, and a point here, m is equal to, well, to go from one point to the other, 1, 2, 3, 4, 5 up, and 1 left. So this is plus 5. If I have to go left, I'm generally going to say that's a negative 1. So negative 1. So the slope is equal to a negative 5. This line here, this horizontal line, well, if I choose this point here and this point here, what's the rise? Well, they don't rise at all. Well, what's the run? It's 1, 2, 3, 4, 5. And 0 divided by 5 is just 0. The next one, a vertical line. Again, if I just choose 2 points on the line, so there and there, I want to substitute again into rise over run. So m is equal to the rise of 1, 2, 3, 4. Over the run, well, it doesn't run from here to here, so that's actually 0. So anytime you're dividing by 0, even if you try and do that on your calculator, it's going to say like undefined or non-real calculation. You can't divide by 0. So we would just say m is undefined. And these rules hold true for every single function that you have. If you have a line that rises from right to left, so any of these lines that rise from right to left, so I'm going up this way, rise from left to right, they're rising. Any line like that will always be positive. If I'm looking at any line that falls as I'm reading across the page from left to right, so like that, or like that, like that, like that, all of those lines as I'm reading from left to right, they fall down. So these always will have a negative slope. Any horizontal line will always have a slope of 0. Okay? And any vertical line will always have a undefined slope. And those are just kind of good rules to know off the top of your head, because if you're looking at a line and you have the slope as positive 5, but it falls from left to right, well, you know you probably did something wrong there and you'd have to re-examine. Okay, so there's kind of the general rule. Any line that goes up from left to right, positive slope, down from left to right, negative. Horizontal slope or horizontal line is going to be 0, vertical, no slope. All right, so let's take a look at a few questions here. So it says, find the slope of the following. Now, I said anytime I have a graph, I always want to do m is equal to rise over run. That's my preferred, because it's going to be the easiest. So they're saying, like, what's the slope of this? If I look at this graph and it goes up, like it's going from left to right, it's going up, I know this should be a positive slope. And so hopefully when I do my work for rise over run, I end up with the same answer, or at least a positive answer. The nice part about this one is they gave me these points. So there's a point here at E and there's a point here at F. So all I need to do is count, what's my rise and what's my run. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 up. 5 to 4 is 9. So that's a positive 9 up. And 1, 2, 3, 4, 5, 6. So plus 6 because I went 6 to the right. And so the rise was 9 over the run of 6. I can leave my slope like that, but generally slope is always represented in lowest terms. So the slope here is, well, technically each of these can be divided by 3, right? So 9 divided by 3 is 3. 6 divided by 3 is, 2. That's a really weird 2. Okay. Which means for every point, there should 3 up, 2 to the right. There should be some other points. So if I go, 3 up, 2 to the right, there should be a point right on that line. 3 up, 2 to the right, point right on that line. 3 up, 2 to the right, and that's how we got to F. Okay. I would invite you just to take a second and pause this one on your own and see if you can figure out what the slope is prior to me talking through it. Okay, so hopefully you pause it and try to figure out the slope for yourself. So m is equal to the rise, so like the rise over run. You can kind of look at this two ways. How did I go from G to H, or H to G, doesn't matter. The thing to know is as I look at this, I know the slope is going down. So I know whatever we do here, we should end up with a negative slope. Well, how do I go from G to H? Well, I'm going 1, 2, 3 down, so minus 3, over a run of 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that right? 4 to, yeah, over 9, right? That was 3 down, so negative, and 9 right, so usually that's positive. Again, I always want to put my slope in lowest terms. So in lowest terms, that's going to be a negative 1 over 3. Which means if I'm trying to find other points, I'm going to go 1 down and 3 right. And that should get me to the next one. So 1 down, 3 right, 1 down, 3 right, 1 down, 3 right. And that's how they went from G to H. Okay. All right, so here's some questions that you actually have to do the slope formula. I mean, you do have an option that you could, sketch these points out. I could say, okay, here's this point at 4, 3, 8, 8, 6, and I could count it out for myself if I wanted to using rise over run. But because I have that formula, I want to employ it. And so remember the formula is m is equal to y2 minus y1 over x2 minus x1. So the slope is equal to, now when I look at these, I just label my points. So this is x1, y1, and this is x2, y2. Alphabetical, right? X, comma, y, and then just whatever numbers as they come in order. So this is point 1, this is point 2. So y2 is 6. So 6 minus y1, which is 3, over y2, which is 8, minus x1, which is 4. So 6 minus 3 is 3, and 8 minus 4 is 4. So the slope of that, the line that would connect those 2 points would be 3 over 4. All right, I'm going to do one more. If you're feeling comfortable with using this formula, I would say take a second, pause this video, and see if you can determine the slope on your own. All right, so hopefully you tried and you designated your points. So this is the first point. I'll call that x1, y1. This is the second point. I'll call that x2, y2. Then I'll take those numbers and substitute it in. Now, a really important thing that comes up in this question is y2 is the negative 2, right? We need to include whatever sign is with that number when we substitute it into the formula. So y2 is negative 2 minus y1, which is a negative 5. So I need to include that negative integer in there when I'm trying to solve. Over x2, which is 8, minus x1, which is 4. So if I'm trying to simplify here, remember, well, negative 2 minus a negative 5 is really like plus 5. So what's negative 2 plus 5? That's 3. And 8 minus 4 is 4. So I actually ended up with the same slope for the line segment connecting those 2 points. Okay. So that's how you use that formula. Please go make sure you try a few questions to make sure you're comfortable using that formula, because this concept of using this formula is a very big part of the next unit that we're going to go into. Okay, one more question, because in case you run into this on the homework, this just says draw the following line segments. This comes up. Oops. Okay. So the first one says beginning at negative 3, negative 2. So I'm going to draw like some line or some graph that has this information with it. So negative 3, negative 2. So negative 3 and negative 2. So there's this point right here. And the slope is 3. So that means to get to the next point, m is going to equal 3. Well, when we talk about slope, we always put that as a fraction. So technically I could write this as a fraction as 3 over 1. Because this is positive, I'm going to go 3 positive up and 1 to the right. So to find the next few points here, I'm going to go 3 up and 1 to the right. So there's a point right there. 3 up and 1 to the right. There'd be a point right there. And then I would just have to sketch the line, ooh, sorry, that's really bad, that crosses through those points. Next one. There's a point beginning at 3, 4, so this point right here. And the slope is negative 2, negative 2 over 3. When I look at that and I say, okay, I have it as a fraction, but how do I know if it's, am I going to go 2, up, down, left, right? Generally, if they give me negative 2, I'm going to go 2 down and 3 right to find the next point. And that should give me my negative slope. So if it's positive slope, go up to find the next few points and right. If it's negative, go down and right. So to find the next 2 down and 3 right, ooh, that'd be a point over here. It's really ugly. But that would be that line segment right there. And I know that's falling from left to right, so that's going to be the correct slope. Okay, so that's the video for slope. If you want to go check some homework, go check homework 1 slope. The blank homework pack is on there, as well as the worked answers. Once you're comfortable, go attempt the quiz on slope, and you only get 1 shot for that. If you have any questions with anything, just fire me a message. Thanks for listening.